Hey everyone, Mr. Fransky here. Today we're going to talk about doing integration with partial fraction decomposition. Partial fraction decomposition. Now you might remember this from pre-calc. We spent some time on this in pre-calc, and we did it in a pretty difficult way because we really wanted to see you guys think critically about this and analytically. Today we're going to learn a little quicker way to do it. But PFD I also think is also kind of funny because it means personal flotation device, like in the water world. But partial fraction decomposition we'll be talking about here. So first thing we're going to do, just kind of warm up, is combine these two rational expressions to a single rational expression. So remember, the way to do that is that we need a common denominator. So I'm going to multiply this guy over here by x minus 3 on the top and bottom. This guy gets a 2x minus 1. Right? Because now I have a common denominator, x minus 3 times 2x minus 1. So if we distribute in the 5 here, 5x minus 15 over x minus 3, I'm going to leave it factored, 2x minus 1. Minus 2 times 2x is 4x minus 2 over x minus 3, 2x minus 1. The thing people always forget to do is distribute this negative here, but you have to. So we have now 5x minus 15 minus 4x plus 2, because the distribution is negative, over, now let's FOIL that out. So we have 2x squared minus x minus 6x is minus 7x, and then plus 3. Okay, so altogether 5x minus 4x is x minus 13 over 2x squared minus 7x plus 3. Okay. So we've now combined our two separate rational expressions to be a single one by using common denominator. That's all we had to do. Spent a lot of time doing that in pre-calc, so I'm going to count on you guys knowing that. Now, so the question is, can we go backwards? Can we go from this to break it up into the two pieces? And it's kind of hard because this x minus 13 came from like all of this different stuff put together. The bottom we can factor, that's not too bad, right? But the question is, how do I get this 5 and this 2? Okay, now first let's talk about why this is important. If you're asked to integrate, this was the answer that we just got by doing that warm-up question, right? If you're asked to integrate this, it's pretty hard. You might think maybe u sub, so it's like, okay, maybe u is 2x squared minus 7x plus 3. Then du would be 4x minus 7. Uh-oh, I do not have 4x minus 7 on the top, right? So u sub is not going to work. But if I could somehow break this up into those two pieces, so this is why going backwards is so important. This is much easier to do, right? Integral 5 over 2x minus 1 dx minus integral 2 over x minus 3 dx. Pull out the constants. 5 integral 1 over 2x minus 1. Make that a 5. Minus dx, excuse me. 2 integral 1 over x minus 3 dx. Now, these are really easy. You could do u sub on them. Eventually, I'm going to hope that you guys get to a point where you don't have to do u sub on a problem like this. But over here, if I had u is 2x plus 1, then du is 2 dx. I need that too. Put it up here. Put a 1/2 out front. So the 2 dx becomes a du. This is now 2 over u. This is going to be 5 halves ln absolute 2x minus 1. And then over here, we have minus 2. If we did u equals x minus 3 here, then du is just dx. So this is just 1 over u du. So this is ln absolute x minus 3, and then of course plus c at the end. Look at how easy that integral is, right? In fact, we probably could have gone straight from here to the final step without having to think much, right? You have 5 halves here. This is just a 1 on the bottom, so you just have a 2. But that's it. That's all there is to it. Okay, so if we can somehow write our equations like this, that is going to be great. Absolutely. Sometimes you see people get sneaky with the subtraction. They use log rules. They put these up to exponents, and then the subtraction turns into division. But if it's a free response question, you don't have to do that. So let's take a look at it like this. All right, let's see what's going on. So here's how to do it the fast way. So I'm going to break this up into the pieces. I should be able to break this up into 5 over 2x minus 1 and 2 over x minus 3. So the first thing I'm going to do is factor the bottom. So PFD, and I should have mentioned this on the last slide. When do we use it? We use it whenever we have a factorable denominator and u sub doesn't work. So we use PFD when it's a factorable denominator. Ooh. Oh my goodness. Factorable denominator, and u sub doesn't work. So as we saw, When I tried to do u sub, I got 4x minus 7. That's not what I have on the top. If I did, though, if I had 4x minus 7 on the top, I would just do u sub on this problem, right? I would not have to do PFD at all. But we don't, okay? So u sub doesn't work. So let's see if we can factor the bottom. So I'm going to focus just on the fraction, and then we'll come back to the integral at the end. So if we factor here, we have x minus 13 over, if we factor this, we get 2x and an x. 3 is going to have to be 3 and 1. Let's see, I want the 3 over here because that'll make a 6, and the 1 here is 1 more x, so minus and minus. Okay. Let's see if that's right. Yes, 2x minus 1 and x minus 3. So now we should be able to break this up with something over 2x minus 1 and something over x minus 3. I don't know what those somethings are, so I'll put an a and a b there. Okay, so basically what I'm doing is I'm searching for the 5, and it looks like a negative 2. I'm searching for those. I don't know what they are, right? Okay. So now, if you multiply both sides by the denominator to the left side, we'll have x minus 13 equal to, so what I'm doing here is I'm multiplying the entire thing by 2x minus 1 times x minus 3. So on the left side, it just cancels. On the right side, part of it goes away from each one. So I have a times x minus 3 and b times 2x minus 1. Now, in pre-calc, what we would have done here is we would have done ax minus 3a, 2bx minus b, and then we would have equated coefficients. So we'd have like a plus 2x equals 1, and then negative 3a plus, minus b equals negative 13. We would have made a system. There's a much easier way to do it. This has to be true for any value of x. So we're going to choose some really convenient values of x. What would one really nice value of x be that would maybe make something over here go away? Well, how about 3? So if x equals 3, then I have 3 minus 13, which is negative 10, is equal to, the a part goes away, right? Because if x is 3, this is 0, it's nothing. But then I have b times 6 minus 1 is 5 equals 5b. So what's b? b is negative 2. All right, found part of it already. What would another really nice value of x be? What would make this 0? I think 1/2. So if we have 1/2, we have 1/2 minus 13. Well, 1/2 minus 13, let's see, 13 is 26 halves, so 1/2 minus 26 halves is negative 25 halves, is equal to, if we put 1/2 in here, 1/2 minus 6 halves is negative 5 halves, a, and this part goes away. That's why we chose 1/2, because it makes it go away. Multiply by negative 2/5, the 2's cancel, the negatives go away, and we just have 5, so a is 5. Look at that, way faster partial fraction decomposition than anything you ever did in pre-calc, right? So now what we have is, this integral is equal to the integral of a we've said is 5, so I have 5 over 2x minus 1. B is negative 2, so you have choices. You can either do plus negative 2 or you can do subtraction like we have it written over here. Either way. Negative 2 over x minus 3 dx. And now we solve that integral, which is exactly what we did over here, right? We split it up into two different pieces. We now have linears on the bottom, which are easy to integrate using absolute value. So you can rewind the video and watch me solving this part. I'm not going to do it again, but so I'm just going to do a kind of a dot, dot, dot. So this ended up being 5 halves ln absolute 2x minus 1 minus 2 ln absolute x minus 3 plus c. So, straightforward partial fraction decomposition problems, really not that hard. You just have to remember that if it's factorable on the bottom and u sub doesn't work, you've got to do it. You have to do the partial fraction decomposition. If the degree is bigger or equal on the top, equal, sometimes, especially if they're both linear, you can use back subs. So like if you had integral like x plus 1 over x minus 1 dx, I would not think about partial fraction decomposition. Here I would do u equals x minus 1. And then I would back solve for the x here. So x would be u plus 1. Put that right here. You'd have u plus 2 on the top. On the bottom, you just have u. You can split it up, right? But if it's bigger on the top, we can't do partial fraction decomposition right away. What you do is you do long division. This doesn't come up very often, but we have to do it because AP could give it to you. I've never seen one, but it could happen. So we're going to long divide first. And then we're going to do PFD on the remainder. And you'll see why that's essential later. Okay, so we're going to long divide this. So we put x squared minus 1 into 3x to the 4th. And I like to have the zeros in here because then it's placeholders, right? 0x squared, 0x plus 1. Probably haven't done this in a while. It's important that we know how to do this, though. X squared into 3x to the fourth, that's 3x squared. Right, 3x squared times x squared gives us 3x to the fourth. Remember, we subtract, ringing some bells hopefully. 3x squared times -1 is a negative 3x squared. This is why I like to have the zeros, because I can line it all up. So you subtract, these go away. 0x cubed, I don't have to worry about bringing down. 0 minus a negative is a positive 3x squared, plus 0x plus 1 comes along for the ride. X squared into 3x squared is 3, so we have a plus 3 at the end. 3 times x squared is 3x squared, that was the whole point, get it to go away, minus 3. These go away when I subtract. 1 minus a negative 3 is a positive 4. So this is equal to the integral of 3x squared, jumping ahead, 3x squared plus 3 plus our 4 is still trying to be divided by x squared minus 1. So now you can see the beginning of it is easy, right? This is the part I have to do the partial fraction decomposition on. So it's an extra step whenever you have a bigger degree on the top, because you have to do this division first and then you have to do partial fraction decomposition, but just do it. Right? If you sit there hemming and hawing and trying to find an easier way to do it, it's going to take you forever, right? So just go ahead and do it. Just do the division, and now we're going to do partial fraction decomposition on this guy. So I'm just going to focus on that for a second. So that's 4 over x plus 1, x minus 1. Right? Factorable denominator. U sub is not going to work because I have no x on the top. So that's going to be equal to a over x plus 1 plus b over x minus 1. Generally, people just skip right to this. 4 equals a times x minus 1 plus b times x plus 1. Now, if you do that, wow, I'm just jumping all over the place. If you do skip straight to here, just remember that the b is over the x minus 1 and the a is over the x plus 1. They kind of switch places. So now let's pick some convenient values. Let's do x equals 1. If x is 1, I have 4 is equal to 2b. 2b or not 2b? b is 2. If x is negative 1, then I have 4 is equal to negative 2a. The b goes away, so a is negative 2. So let's see what we have here. We have integral 3x squared plus 3 plus negative 2 over x plus 1. This is the partial fraction decomposition of the 4 over x squared minus 1. Plus b is 2 over x minus 1 dx. Nice linear things. There's no coefficients. So let's do the antiderivative here. So this is going to be 3x cubed over 3. Hey, the 3's cancel. That's nice. Okay. And then plus 3x. And then minus 2 ln absolute x plus 1. Plus 2 absolute ln, excuse me. And then we'll fit this in here. We'll see. ln absolute x minus 1 plus c. There's our answer. So you see, basically the long division gives us some polynomial things out here, and then we have the partial fraction decomposition on just the remainder. Cool. Got one more. So factorable denominator, it's almost already factored for us. So this is integral 6x squared minus 8x minus 4. You've got to factor this first part, right? So it's x plus 2, x minus 2 times x minus 1. Ooh, 3 factors. Oh boy. Okay, so let's just focus on this right now. So we have 6x squared minus 8x minus 4 divided by x plus 2, x minus 2 times x minus 1. See if my computer battery holds out here. Alright, so that's going to be equal to a over x plus 2, b over x minus 2, and c over x minus 1. Multiply by the entire denominator, we have 6x squared minus 8x minus 4 equal to a x minus 2 x minus 1, right? The only part that goes away is the x plus 2, because we're multiplying by the entire denominator, the x plus 2 will cancel. Then we have b times x plus 2 x minus 1, and c times x plus 2 x minus 2. Alright, first convenient value for x. Well, let's do, I don't know, 2? Sure. So if x equals 2, then we have 4 times 6 is 24, minus 16 minus 4 is equal to, let's see, the a goes away, the c goes away, we're stuck with the b. So we have 4 times 1, so we have 4b. Okay, following that along, 24 minus 60 is 8, minus 4 is 4. So 4 equals 4b, so b is 1. All right, another convenient value. How about 1? So x is 1, a and b go away. We have 3 times negative 1. So we have negative 3c. Hold that for a second. So we have 6 minus 8 minus 4 equals, we say, 3c, negative 3c? 3 times, anyway, yeah, negative 3c. So that means that we have 6 minus 8 is negative 2. So we have negative 6 equals negative 3c. C is 2. Last good one, negative 2. So we have 6 as 24 again, this time plus 16 minus 4 is equal to, so let's see, b and c cancel. We have negative 2 minus 2 is negative 4 times negative 3 is a positive 12a. So 24 and 16 are 40, minus 4 is 36 equals 12a. A is 3. Hey, nice numbers. Okay, so this is equal to the integral of, let's see, a over x plus 2. That's 3 over x plus 2. B is 1, so plus 1 over x minus 2. And c is 2 over x minus 1 dx. Easy peasy. 3 ln absolute x plus 2 plus ln absolute x minus 2 plus 2 ln absolute x minus 1 plus c. Now, one thing to be careful of, if there's a number down here, like a 3 or something, you can't just throw it in here. You have to remember to do the divided by 3 out front, right? You're technically doing u sub, right, on all of these, but because they're all linear and there's no coefficients, I can just do natural log. It's not too bad. Cool. All right. So this is the extent, this is about as difficult as I expect you guys to be able to do partial fraction decomposition. The dividing thing is kind of weird, right? So these are kind of the big things I expect you to be able to do. So preference for solving integration problems. First thing, you got to know those 13 cold, right? I don't know how many times I've said this. You have to know those 13 really well, because if you have one of those, you have to just be able to do it automatically. Next, I would always try u sub, okay? Including back substitution, especially on the linear over linear problems. And then, if neither of those work, you go to partial fraction decomposition if you have a factorable denominator, or use integration by parts, the uv minus integral b du. Now, I probably gave you a challenge problem. It was probably this one. I love this problem. In this one, I've never seen AP give you something where you had to do an irreducible quadratic, but you may remember if you have you're factored on the bottom as an x squared plus 1 times x minus 1, something like that. This is an irreducible quadratic. I cannot factor it anymore. So when you do your letters, you have to do an ax plus b over x squared plus 1. I don't really want to go into theory on that. We talked about it a lot in pre-calc. But basically, you need to donate as many x's as possible. So this top has to be just 1 degree less than the bottom. So you have c over x minus 1. The other one is if you have a repeated factor. So you have like x minus 2 squared times x plus 1, something like that. You have to do each iteration of x minus 2. So you have a over x minus 2, b over x minus 2 squared. And you have c over x plus 1. This is just stuff for like challenge type problems. I've never seen AP give something like this. They're mostly concerned. They usually give you multiple choice problems where the bottom's already factored, and they just want you to be able to show that you know how to do partial fraction decomposition. But if you do want to try this bonus problem, I think this is the important one, is that if you have an irreducible quadratic, that you do just 1 degree less, so ax plus b over x squared plus 1, and then the partial fraction decomposition is a little bit hairier, but it's not terrible. Okay, so that's partial fraction decomposition. I hope that it's not too bad. I love you guys. That's why I'm here. Have a great day.